All right. Good afternoon from whenever. Good morning, good afternoon, good evening from whenever you're joining from. This is Uncle Sam, and this is 4 p.m. West African time. Joining from live from Nigeria, Western part of Africa, and we are here again to learn. I've been going live consistently for since last week, and I've already said it that my days of going live on YouTube includes Mondays, Wednesdays, and Fridays. And the time I go live is 4 p.m. West African time, WAT, West African time. That is the time I usually go live. And what is my main goal? My main goal is simple, to show you beyond knowledge to gain understanding. And we explore math related concepts, trying to break it down. We've been considering indices since last week. We're going to be wrapping up because the last part of indices that we're going to be discussing is indices that involve quadratic equation. We've examined the indices that involves linear equation on Friday last week, and also on Monday this week we explored indices that has to do with simultaneous equation, that is two linear equations being solved at the same time. And now for today, to wrap it all up on indices, we're going to be discussing about quadratic equations involved in indices, and it's going to be interesting. Trust me, it's usually very interesting. So thank you so much for joining. Now we're going to get into what we have for today. Now, quadratic equation under indices. We already know that the concept of the quadratic equation goes this way. Now, this is the basic idea of a quadratic equation. If you're talking about a quadratic equation, you're looking at an equation in which you're supposed to get two values that will satisfy the given expression. Look at the format. The format is ax squared plus bx plus c equals to 0. Now, the whole left-hand side is equal to the right-hand side. That is the whole point of an equation. I keep saying it. Two things that you generally need to look at anytime you're considering an equation is, first, an equation must have an equality sign. That's one of the things you look at. And an equation must have a variable, something that you're looking for. And in this case, this thing that we're looking for, which is our x, is now squared. That means you're supposed to get two values of what? The variable that we're looking for that will satisfy this given expression. The other one, which you considered before, was linear equation, and it didn't require two variables. Just one was enough. For example, you have 2x plus 1 equals to 10. Now, this x here, the power of x here, is just 1, because we're considering indices. We are looking at how we can be able to represent what expression in terms of a base and a power. And indices helps us to bring that into what? Into play. By telling us that this x here actually has a power, and that power is what? 1. And so that is, the x becomes the base, and the power is now 1. So, for this given expression, which is a linear equation, it is only just one value, one value in terms of a numerical value that is able to satisfy this given expression. It is not the same for a quadratic equation. So the first thing I need you to understand before we dive into solving this indices equation involving quadratic equation is, first, realize that since we're talking about what? A quadratic equation, we are looking at what? The variable, we are looking for two values that will satisfy the given equation. And this is the framework for quadratic equation, where you have ax squared plus bx plus c equal to 0. Meaning that for any given equation, any given quadratic equation, we are looking for two values that if you substitute in place of x here and x here, and you resolve this left-hand side, it's going to end up giving you just 0. Yes, it's going to give you 0. That's the whole idea of a quadratic equation. Now, to move forward, we're going to go into seeing some real-life example of how this plays out. We've already been considering indices, and I've told you, I keep repeating it. For the whole session of this indices class, I've been talking about the whole idea, how that indices talks about the concept of index. An index in maths talks about power. And there cannot be power without what? A base. So these three things need to come into play anytime you're discussing about indices. So the next thing I'm going to do now is to go further down to discuss about indices involving quadratic equation. So I'll start with a given example here. So the first example I'm going to be considering is this. We have a given equation here. Solve for x. We're looking for x in this particular question, where you have 2 raised to the power of open bracket 2x squared plus 15x plus 7 equals to 1. Yes, so this is just making sure that the equation is correct. So this is what we have here. We have 2 raised to the power of what? 2x squared plus 15x plus 7 equals to 1. Now, this question already spelled out that, wow, we're actually dealing with indices because we have 2 as the base here, and we have this polynomial expression as our power. So since we know that we're considering indices involving equation, and by extension we're talking about quadratic equation, what can we do here? Well, we're interested in this quadratic equation. The base is not really our concern, although it's going to play a huge role. So the first thing I need to do is there a way I can make these 2, which is the base, to be the same as what is on the right hand side? There's a reason for that. Well, it turns out that I can replace 1. 1 is something as saying anything or any value raised to the power of 0. We know that it's a standard. So if I have a raised to the power of 0 is equals to 1, if I have b raised to the power of 0 is equals to 1, if I have 3 raised to the power of 0 is still equals to 1. So since I have this flair of choosing any value and just raising it to the power of 0, I can just go about replacing this 1 with 2. Why am I going with 2? Well, the base I have on the left side is 2. So it is almost right to change this 1, since I have the liberty to change it to any variable or any value at all raised to the power of 0. I choose to replace this 1 with 2 as the base and 0 as the power. So that's what I'm going to do here. So if I do that, I'm going to represent it as become 2 raised to the power of 2x squared plus 15x plus 7 equals to 2 raised to the power of 0. I told you I had the liberty to choose whatever I'm going to replace this 1 with. I could choose any base and then raise value to the power of 0. It is still going to be equals to 1 according to the laws of indices. But I choose 2 for a reason, so that it will be able to tally with what is on the left hand side. Now that I've done this, do you have any idea what can we do next here? Well, the law in this states that if the base is, so far there is equality sign separating the 2 signs. Since the bases are now the same, then surely the powers must be the same. And so we let go of the base and now examine the power. We equate their power. So what I'm going to do now is going to be 2x squared plus 15x plus 7 equal to 0. So we've left the base. Since the bases are equal, that simply means that the powers must also be equal. And so this is what we have at this point. So now that we have this, it is clearly looking like a quadratic equation, because the framework for a quadratic equation is ax squared plus bx plus c equals to 0. This is the framework. And this satisfies it, where this a is just the coefficient of the highest power of the unknown variable, which is x squared. And this b is the same thing as 15 here, and this c is the constant here, equal to 0. So we can now go ahead and start solving this question. Thank you! Snippy Gold, I just saw your message now. Thank you so much. Thank you. I appreciate you. Balami, Balamalhill, welcome, dude. Thank you so much for joining. I really appreciate you. XM, welcome. Snippy, welcome. Thank you so much, guys. I really appreciate you. Thank you guys for being here. I really appreciate you. So let's continue what we have here. Now that we have this given expression as our quadratic equation, what is the next thing that we're going to do? Well, it turns out that there are varieties of methods we use in solving quadratic equation. We have a number of them. We have the factorization method. We have the quadratic formula method, and then we also have the completing the square method. And each of these methods have their pros and cons. They have where they are very, very useful and where we don't really employ. It's not all of them are very, very important. We're supposed to know all of them. But quadratic formula is usually the best, and I'm going to tell you the reason why it's the best for solving a quadratic equation. The reason is because quadratic method can solve right about any quadratic equation? Yes. Factorization method is very limited. Yes, it's very limited because the concept of factorization method has to do with having to find factors, at least two factors, and in most cases there are some quadratic expression that you are not able to find such factors. Okay, so other than that, factorization method is a piece of a method, and it's super simple. Just know the concept of factors and you'll be able to work, go and solve it. Then the other one, completing a square, it's more like the quadratic formula because the process of getting the quadratic formula involves using completing the square method. I'm not going into all that because I'm not considering quadratic equation today. Rather, I'm going to be using, for this particular case, I'm going to be using factorization method to solve this. When we get to solving quadratic equation and still around, we're going to make it super simple so you're able to absorb what quadratic formula is all about and also the other formulas that governs quadratic equation. So for today's particular video, we're going to be concentrating on factorization method. So to further go into the factorization method, what are we going to do? We have 2x squared plus 15x plus 7 equal to 0. It's now looking like a quadratic equation. What do we do next? Well, applying factorization method. So let me write it boldly. Using factorization method. What do we do to use factorization method? It's quite simple. Factorization method involves it that, let me write the expression out, 2x squared plus 15x plus 7 equals to 0. Now, what factorization method tells you to do is this. We're going to multiply these numbers together. 2x multiplied to 7 is going to give you 14. Sorry, 2x squared multiplied to 7 is going to give you 14x squared. Now, most people tend to forget the x squared, but you can as well skip it. Just multiply the numbers, and there's a reason why we're doing that. Now that you've gotten this number here, remember, take the first variable here, the first expression here, multiply it to the last, which is the constant here. Once you've done that, this is what you have here. Now that you've gotten to this stage, what you're going to ask yourself, think of two numbers that if you add them or subtract the two numbers from each other, either you add them or subtract them from each other, the end product is going to give you 15. You can also say it's 15x. But if you multiply them together, the end product is going to give you this 14x squared. Yes. Think of two numbers. If you add or subtract them from each other, it's going to give you 15x. But if you multiply them together, it's going to give you 14x. There are two values that I know, and that is what? 14x and x. Now, let's prove if this is correct. If I multiply 14x to x, it's going to give me what? 14x squared, just like I said. And then, if I add 14x to x, it's going to give me what? 15x. So what am I going to do? It's more like you rearrange this 15x into those variables using a plus sign. So it's going to be something of this sort. It's going to be 2x squared. We are arranging this whole expression here. It's going to give you 2x squared plus, I will replace this 15x with 14x plus x. 14x plus x. And then plus, leave your 7 the way it is, equals to 0. So what I simply did here, the only thing I did here was to replace my 15x to be what? 14x plus x. Because if you add them together, is it going to give you what? 15x. But I did not just come about this out of my own. I had to employ the certain rule of factors. Remember, two numbers that you can, if you multiply together, they will give you 14x squared. If you add or subtract them together, it will give you what? 15x. And in this case, we chose to add because adding gives us what we are looking for. So at this point now, what do we go about doing? Well, we can now go ahead and factor them. And factoring simply means grouping them in twos. So I'm going to group this, the first two, and then group this also. And once I group it, I look at the expressions inside this bracket that I just grouped for each of them and find what is common. Well, for this 2x squared and what? 14x, something is common. First, 2 is common. How do I know that 2 is common? Because 2 can divide 2 here, and 2 can also divide what? 14. Yes, so 2 is common. And not just that, this expression here has x, which is a variable that we're looking for, and this also has x. So not just 2 that is common, but 2x. Once I find what is common, I'll open up a bracket and what? And then look at what I'm going to do next. This 2x that is common between these two parts now, I'll use it, divide each of the time. So 2x divide 2x squared. It's more like saying 2x squared over 2x. 2 clears up to x squared divided by x, we just leave it with x. So what we have remaining here is just what? X. Plus 2x goes on to divide what? 14x. It's more like saying 14x over 2x. X clears out, 2 divided 14 is going to give us what? 7. So this is what we have. So that you go ahead to multiply this back. 2x multiply everything here. 2x times s will give you 2x squared. And then 2x multiplied to 7 will give you 14x. So we've not really done anything much here. We are just what? We are just simplifying it. And this process is called factorization because it's factorization method that we're using to solve. Okay? Then you have your plus sign. And then you look at this expression here. What do you think is common between x and 7? Well, you might look at it and say, nothing is common between x and 7, but something is. Just like you say that if I have a now, and I ask you, this is a, it's all alone, but what is the coefficient of this a? That is where you now remember, oh, there's an invisible 1 here. So you now tell me that the coefficient of a here is 1. Now, 1 is more like an invisible or a default coefficient for every number, and it's also a default divisor. 1 can divide through what? X, and can divide through 7. So in that case, what is common between them is 1. Why? There must be something common so that we can carry out this process that I just spelled out here. There must be something common. And when there is no obvious thing common, you use 1. Because if I use 1 now and say that 1 is a common thing between them, 1 divided by 1 divide x is simply like saying x over 1. And that also give me x. So I put my x here. Plus 1 divided 7 is simply like saying 7 over 1. And that will still give me what? 7. So nothing changed. But the fact is still remains that we need something that is common. We need to factorize. We need to find something that is common between the two and factorize. That is what we're simply saying here. And I will equate this to 0. That's what I'm going to do. And then, remember that we'll use 1 because by default I already told you that any variable that does not have a coefficient by default has a coefficient of 1. Same way, any variable or expression that you're trying to factorize and there is no obvious value that is common to both of them that you can bring out and then use to simplify to put inside a bracket, you use 1. Because if I use 1 to go on and expand this, 1 multiply x will still give me back my x here. 1 multiply 7, so nothing changed. But we need that 1 to be visible. So now that we've gotten to this extent, you see now that this is the same as this. So we're just going to pick one of it. And then these things that we factored out, we'll put it inside a separate bracket. So this becomes 2x, which is this, plus our 1. We'll put it inside the bracket, then open another bracket and put my x plus 7. Everything equals to 0. This is simply what the factorization method is all about. But we're not done because the question says we should find what? Solve for x, we should find the value of x. So what do we do at this point? If 2x plus 1, close bracket, another x plus 7 equals to 0. If two things multiplying themselves equals to 0, it simply means that each of the expressions are equal to 0. So what do I mean by that? If 2x plus 1, close bracket, open bracket, x plus 7 equals to 0, it implies that 2x plus 1 equals to 0 and what? X plus 7 equals to 0. Yes, if two things, when they multiply to themselves, they are equal to 0, then individually they are equal to 0. That's what equation, quadratic equation tells us. And if that is the case now, we can go ahead and find the value of x for this part by what? First, subtracting 1 from both sides. If we subtract 1 from this side and this side, it's going to be 2x plus 1 minus 1 equals to 0 minus 1 for this part. And in here, we subtract 7 from both sides just to make x subject of the formula. If we subtract 7 from both sides, it's going to be x plus 7 minus 7 equals to 0 minus 7. That's what we're having here. And if we go ahead to do that, you're going to have that you're over here, this plus 1 will cancel the negative 1. And what you're left with is 2x equals to 0 minus 1 will give us minus 1. And then we'll divide both sides by the coefficient of x. What is beside x, which is 2. So if you divide here by x, by the coefficient of x, which is 2, divide here by 2. So, and you do the same thing here. If you subtract 7 from both sides, 7 cancels 7. And all you have remaining is that your x is equal to negative 7. But for this side, let me clean up here and continue. I'm going to clean up here, but I need to leave this equation. I'm going to clean here because we're going to be testing this equation after everything. So Here now, we've divided both sides and x is just remaining on this left hand side. It implies our x here for this part is equals to minus 1 over 2, or that our what? X here is equals to negative 7. Now I want to correct myself because I said something that might not be entirely true. Let me correct myself. So I just realized that I said that if 2x plus 1 and x plus 7 equals to 0, it implies that 2x plus 1 equals to 0. And it's not supposed to be and, it's supposed to be or. I just wanted to correct myself on that. Sorry about that. Because if these two things multiply themselves and they are equal to 0, there are chances that either this one is equal to 0 or this one is equal to 0. So that once this one is equal to 0 and this one is not equal to 0, anything multiplied to 0 will still give you 0. So that's how we say it, or that's how it's done in what? In quadratic equation. Okay. Thank you, Bahami. Gloria, thank you so much. I should use quadratic formula. Okay. Maybe after I'm done now, I'm going to use quadratic formula to solve it. Okay, I'm going to use quadratic formula. Thank you so much. Random Mexicano. Thank you so much. Thank you. I really appreciate you. I'm going to use quadratic equation to solve it once I'm done. So, but this is the end product. We see that for this to be true now, x is equals to minus 1 over 2, or x is equals to what? Minus 7. Simply telling us that x is equals to minus 1 over 2 or minus 7. This is the value of the x that will satisfy this quadratic equation to be equal to 0. But we cannot say for sure. Do you think so? Just by solving it, just because we solved it and we got this answer or we arrived at an answer, does not make what we solved to be true. Because if you give somebody that doesn't know math an equation to solve, they will probably write something and they will probably come to a conclusion and tell you that this is the answer. But the thing is, when you're solving an equation, did you follow the right step? That is what makes your answer closer to what is expected. Did you follow the right procedure? And you cannot know for sure if we don't take what you got and plug back into the given expression. Maths affords us that luxury to take our solution, whatever we got, result, plug it back into the given expression, one after the other, and simplify it and see if it actually gives us what we presume that it does. So this is what we're going to do now. So since we have arrived that our x is equal to negative 1 over 2, or that our x is equal to negative 7, we cannot say for sure. So we're going to prove. To prove that. And after I prove that, I'll now use the quadratic formula to solve this equation again for the person that requested for that in the chat. So let's prove that in here. So if our x is equal to negative 1 over 2, or x equals to negative 7, remember now, the whole idea of a quadratic equation is that you're going to get two values for the unknown variable. In this case, we use x. So I've gotten the two values. And simply means that the two values, if you substitute it in this given expression and simplify it, it should give you 0, because that is the whole idea of a quadratic equation. So let's get into it. So if we replace this our x with, let's start with negative 1 over 2. So this becomes 2 open bracket negative 1 over 2, everything squared. So I'm replacing, anywhere I see x, I'm replacing with negative 1 over 2 to test if this result that I got here is actually what it's supposed to be. That's what I'm doing here. So if I do that, plus 15 multiplied to negative 1 over 2 plus 7, is it really equal to 0? Here I'm testing, so I'm using what? A question mark to denote that. So we'll go on to simplify this. Well, this is the same thing as saying if I have half minus half squared, is it not saying minus 1 over 2 multiplied to minus 1 over 2? And the first thing that will multiply is that negative multiplying negative is going to give me a positive, meaning that the entire answer I'm going to get after I multiply this is going to be a positive value. So it's going to now be 1 multiply 1 and 2 multiply 2 will give me 4. So the answer to this is going to give me 2 open bracket 1 over 4. I've actually expanded this. That's what I did here. Then plus 15 multiplied to 1 over 2. I can go on to simplify this. How do I simplify this now? Since this is plus 15, because if you don't know already, sign comes before any given number in math. Sign must come before. So this plus here belongs to 15. It does not belong to this side. It belongs. So that is telling you that this 2 here has its own sign, but it's invisible, it is a positive sign. So since this sign belongs to 15, it's more like saying 15 here, this plus sign multiplied to this minus that this 1/2 has, in order to simplify, because we're simplifying at this point. So plus times minus is going to give you minus. So that means the entire thing we're going to have here is now a minus, no more a plus. And then if you use 15 to multiply 1/2, it's going to give you 15/2. I've not really done much. I didn't do anything more. It's just like opening up a bracket. If I have, because I like to simplify whatever process that I'm doing. If I have, let me use here. If I have 2 multiplied 1/2, it's not hard for me to know that this is something as saying 2 times 1/2, and that's going to give me 2/2 equals to 1. Because this 2 here by default has a denominator of 1. Because that denominator of 1 does not really affect anything. It doesn't. 2 divided by 1 will still end up giving us what? 2. So I've not really done anything strange. Math affords you that luxury, that liberty to do this, to employ 1 where it is necessary. And if you employ that 1, what is simply happening here is the numerator will now multiply the numerator, and the denominator, which is the one that you made to be visible, although it has always been there, becomes visible, and it now multiplies the denominator here. And that's why we ended up with what? 2/2, because 2 times 1, 2. 1 times 2, 2. And if you divide it, it's going to give you 1. So if I have the same expression for this side that now has a negative, so I have 15, then multiply to minus 1/2. What is happening here is this 15 has an invisible positive sign. So before anything, before numbers multiply in math, I need you to know this. Before numbers multiply, their sign multiply first. Let us think in for a minute. Before numbers multiply, their individual signs must multiply first. So because there's an invisible multiplication sign here, or invisible addition sign here, sorry, it will go on and multiply the what? The negative sign here. And one know that a plus multiplied to minus is going to give you what? Minus. Positive multiply negative will end up giving you negative. So that means the answer I'm going to have here is going to be negative first. And like I did for the previous example, this 15 has a denominator of 1. Yes, because it does not change anything. Still, 15 divided by 1 is still going to give us what? 15. So what happens now is this 15 will now multiply the numerator for this section, and the 1 here multiplies the denominator. So it's something as 15 multiply 1, 15 now. 1 times 2, 2. That is why I'll have this one, minus 15/2. I hope that is clear. So let us continue. If we continue here now, this is going to be plus 7 equals to 0. Well, let's go and simplify this. 2 multiplied to 1/4 is still going to end up giving us 1/2. Let me just first read that so we can go to the next example. Minus 15/2 plus 7. Now what I'm going to do here next is just to simplify this. Since I have 1/2 minus 15 plus 7 equals to 0, forgot to add. And then I'm going to, you know that this 7 by default, since I've started talking about the concept of having a denominator of 1, this 7 has a denominator of 1, and this also has a denominator of 1. So if that is the case now, we're going to apply what? The fractional way, addition of fraction method. So this is going to be 1/2 minus 15/2 plus 7/1 equals to 0. The LCM here is C2. 2 divided by 2 here is going to give us 1. 1 times 1, 1. Minus 2 divided by 2 here is going to give us what? 1. 1 times 15 is going to give us what? 15. Then plus 2 divided by 1 here is going to give us 2. 2 times 7 is going to give us what? 14. Is it equals to 0? We are about to find out. So 1 minus 15 is going to give us minus 14. Minus 14 plus 14 is going to give us 0/2 equals to 0. And anything, 0 divided by anything is going to give us what? 0. So 0 is equals to what? 0. So you see that this actually came out to be actually true. Yes. And so this expression minus 1/2 actually satisfied the given quadratic equation that was solved originally. It satisfied it because it gave us 0 on the left hand side. That is what we have after. And so now that we've confound it now, let us confirm the other one, which is not going to take time because it's just a whole number. So we're going to replace in this expression again, replace anywhere we see x, replace it with what? -7. So when x equals to -7, what are we going to do here? Now I'm going to have that this become 2 open bracket -7 squared plus 15 open bracket -7 plus 7. Is it equals to 0? Let's find out. The negative 7 squared is just like saying minus 7 times minus 7. And minus multiplying minus is going to give us what? A positive. So since it's a positive, what's going to happen is now 7 multiply 7 will not give us 49. So this is simply saying 2 multiply 49. Then here, the positive will go and multiply the negative because I already said it. I keep saying it. When two numbers or two variables are multiplying, you are not seeing the full picture. The full picture that I want you to know is this. The sign multiplies first before the number. So if you have that in mind, you always be conscious of sign. One of the things that trick people a lot in math is sign. Not being able to appropriate the sign where it is needed. So in this case now, this positive will go to what? Multiply the negative here. And that's going to give you what? Negative. And then you're not going to have 15. We can still leave it as 15 multiply, or let me just multiply it out. 15 multiply 7, 7 times 15, 7 times 5, 35, 7 times 1, 7 plus 3, 105, and then plus 7 is equal to 0. Now 2 times 49, let me do that somewhere here. 49 times 2, 8, 2 times 8, 2 times 4, 8 plus 1, 98. So this is simply like saying 98 minus 105 plus 7 is equals to 0. We are about to find out. Well, if I add 7 to 98, 98, 99, 100, 101, 102, 103, 104, 105. So it's going to give me, if I add this together, it's going to give me 105 minus 105. Is it equals to 0? Yes, because 105 minus 105 is equals to 0. So these two values for x that we solved and we got for this given quadratic equation satisfy the concept, the whole idea of what a quadratic equation talks about. Because a quadratic equation tells you that you're going to get two values for the variable that you're looking for. And those two variables must be able to satisfy the expression. Making it what it simply means is that when you substitute those variables that you got into the original expression, it's going to give you what? 0 as it is on the right hand side. So that is the whole idea. So I hope that is clear now. So based on request, I'm going to be solving this particular question again using quadratic formula, and that's quite simpler and the faster. So I'm going to clean here. Please make sure that you take a screenshot or you're getting it. If you have any question of any sort, please leave it in the comment section and I'm going to attend to you. Thank you very much. So good to have you guys here. Thank you for joining, guys. Thank you. Thank you. So at this point now, we're going to use factorization method to solve earlier. We're now going to use quadratic formula. So we're going using quadratic formula. Now, while growing up, they used to call this the almighty formula. And I kept on wondering, why is it called almighty formula? It was such a thing when I was still in high school. Until I discovered that the reason why this is called quadratic formula, or aka almighty formula, is because it can literally solve any quadratic equation at all. Any quadratic equation, it can solve it. But factorization method, which you used earlier, is limited. It only works when you are talking about factors related quadratic expression. But for the quadratic formula, it doesn't care. It solves everything. So let's use quadratic formula to solve this given expression to see if we're going to arrive at the same answer. So how do we do that? Now, using quadratic formula, what is quadratic formula? Quadratic formula says that x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Now, this might look a little bogus to you, but this is the whole idea of what a quadratic equation is. The framework for a quadratic equation is such that if you have ax squared plus bx plus c, everything is equal to 0. So this framework is what was used to determine this quadratic formula, where your a is the coefficient of the variable with the highest exponent, which is the highest power. That's what you have here. And then your b is the variable is the coefficient of the variable with the lesser power than the highest. That's how it's done. And then c is your constant. And so let's use that. So what we need to do here is to, from this given quadratic equation, identify what is our a, our b, and our c. I'll just substitute it into this given expression. I will simplify. Remember, we solved originally, and this is the value that we got using factorization method. So we should be aiming at getting the same value using this quadratic formula. So how do we go about doing that? Well, simply let us define the value of a. So since this is x squared, this one with the highest exponent, these two, our a becomes 2. Then our b becomes 15. and our c becomes what? 7. Now that we've gotten that, we'll go ahead and substitute it here. So it means that our x will now be equals to negative 15, because our b is equals to 15, plus or minus square root of b squared, which is 15 squared, minus 4 multiplied to a is 2, and multiplied to c is what? 7. Then everything all over 2a. 2a is same as 2 multiplied the value of a, and our a is equals to 2. So this is what we have here. So let's go ahead and just simplify it. So if we go ahead and simplify, it's going to give us that x is equals to negative 15. Let's leave it here. We're not touching you yet, so it's going to come back to you, bro. Then 15 squared is going to give you, I think it's about 225. Then minus 4 times 2 is 8. 8 times 7. 7 times 8 is 49, 56. So we're going to have 56 here. 56 here. Good. All over what? 2 times 2, which is what? 4. So let's go ahead and subtract this. 225 minus 56. So 1 cancel 1, borrow 1 from here, add it here, remaining 1. 15 minus 6 is going to give us 9. Borrow 1 from here, add it here. Here is remaining 1. This becomes 11. 11 minus 6 will give us what? 11 minus 5 will give us 6. And you bring out the 1. So you have 169 remaining here. So this becomes that our x equals to minus 15 plus or minus square root of here is now remaining 169 all over 4. So we can find the square root of 169 because 13 times 13 will give us 169. That means the singular value that multiplied itself to get 169 is 13. So we replace this with 13. It becomes that our x is equal to minus 15 plus or minus 13 over 4. Now, plus and minus simply being implies that it can be 15 plus 13 all over 4, or it can be 15 minus 13 all over 4. So you solve for each. If you solve for each, you're going to have 15 plus 13 is going to give us 28 all over. Oh, I forgot there's a negative here. I forgot that there's a negative here. So one moment, remember there's a negative here. So it's simple as saying, this implies that it's simple as 15 minus 15 plus 13 all over 2 all over 4, or minus 15 minus 13 all over 4. So what I simply did, since you're having a plus and minus here, it means that this value can either be on the plus or minus side, and you're going to be expressing it in that way. That means if you consider simplifying this based on the plus sign, you also consider simplifying it based on the minus sign. That is what it simply means here. So here, for this part now, it becomes that, for this part, minus 15 plus 13 is going to give us minus 2 over 4. And that's going to give us, if we reduce this, minus 1 over 2. Voila! It's giving us what to arrive at originally using factorization method. If you do the same for this one, minus 15 minus 13 is going to give us minus 28 over 4. And that's going to give us minus 7. So voila! We got the same value. So using quadratic formula, or aka almighty formula, like we used to call it in high school, we've arrived that the same expression we solve using factorization method equally applies when we use factorization method, which is telling you that we're actually on the right track. So everything summed up together, we are having it. And so one final thing that we're going to do before we go into solving the next question under this particular question is this. Now that we have determined when we substitute the value of x to be either minus 1 over 2 or x equals to negative 7, we got the whole side to be equal to 0. One final thing that I want you to know is this. Since we substituted the value of x to be either minus 1 over 2 or minus 7, and we got here to be equal to what? 0 in the end when we simplify everything. Okay? It means that if everything here, when we simplified it, either adding minus 1 over 2 as our x and simplifying, or adding minus 7 as the value of our x, if it's equal to 0 in the end, it simply means that what we will have here, if we are to substitute, is going to be 2 raised to the power of 0 equals to 1. And is 2 raised to the power of 0 equals to 1? Yes, so it simply means that 1 is equal to 1. So that equally satisfies the indicial equation originally. That is the whole idea. Isn't this beautiful? Thank you so much. So take a screenshot, guys, if you may. We're going to solve one more question, and then I'll now introduce the topic that we'll be doing next on Friday, because this is the height of it, solving indices involving equation and examining it under quadratic equation. So take a screenshot now. I'm going to be cleaning in 5, 4, 3, 2, and 1. One more question, guys. Let's go. We're going to solve a much interesting question. The one that will have to do a form of reverse engineering. Reverse engineering. So look at this question. Solve the equation. Solve the equation. Solve the equation. What is the equation? 4 raised to the power of 2x minus 3 minus 3 open bracket 4 raised to the power of x minus 2, okay, minus 1 equals to 0. Well, this is what we have here. And to get started, solution. To get started, what can we do here? Well, we know from the basic law of indices that if you have an expression, let's say that this was multiplication, we'll have just applied the first law of indices, which is multiplication of expression that have the same base, simply mean pick out of the base and add up the power. But we can't really do that here. And since you already have an idea that what we're discussing is quadratic equation in indices, we can actually reverse engineer, okay? Because how was this 4 raised to the power of 2x minus 3 gotten? If you can agree with me that it was gotten when something like 4 raised to the power of 2x was divided by 4 raised to the power of 3. Yes. So if you apply the rule of division under indices, since the bases are the same as 4 raised to the power of 2x, division changes to what? Subtraction, and then you subtract just the power. Pick one of the base and then subtract their power. This is how this part, which is this, was gotten. And in the same line, this 4 raised to the power of what? X minus 2 is same thing as 4 raised to the power of x divided by 4 raised to the power of 2. So that if you pick one of the base and then you subtract the power x minus 2. So what I mean by reverse engineering is just, this is the product that we are giving. We're going to engineer it back to be in this form. And I've already given you a highlight of how this is going to be. So I'm going to just simply substitute that. So this is the same thing as 4 raised to the power of 2x divided by what? 4 raised to the power of 3. Close your bracket. Minus 3. This is the same thing as what? 4 raised to the power of x divided by 4 raised to the power of 2. Then minus 1 equals to 0. So this is what we have at this point. I've actually reverse engineered the math to give us the original expression that gave birth to this. Because if you solve this now, we're going to get back this. Because it's division of indices according to the law. So what do we do here? Well, I know that division is same thing as over. So I can represent this as 4 raised to the power of 2x divided by 4 raised to the power of 3 for this part, minus 3 into, do the same thing here, 4 raised to the power of x divided by 4 raised to the power of 2 minus 1 equals to 0. So what can I do here now? Well, look at what I'm going to do. What I'm going to do here is I want to clear the fraction. How do I clear the fraction? I'll say multiply through by or with. Multiply through means multiply everything, both what is on the left and what is on the right. Multiply through with 4 raised to the power of 3 because it's the highest power here. So if I do that, it's going to be 4 raised to the power of 3 multiplied to 4 raised to the power of 2x all over 4 raised to the power of 3 minus 4 raised to the power of 3 multiplied to 3 into 4 raised to the power of x over 4 raised to the power of 2. Close this bracket. Then minus 4 raised to the power of 3 multiplied to this one here equals to 0 multiplied to 4 raised to the power of 3. Because that's the whole point of saying multiplying through by 4 raised to the power of x. That's what it simply means. So what will happen is this clears out this. That's what happens. And then 4 raised to the power of 3 divided by 4 raised to the power of 2. One of the power will be subtracted because this is divided now. It's going to subtract one of the power. Okay? And then what you have remaining is just 4. It's just 4 that is remaining now. Because this is same thing as saying 4 raised to the power of 3 over 4 raised to the power of 2, which is same thing as 4 times 4 times 4, and 4 times 4. 4 cancels, 4 cancels, you're just left with 4. Just making sure that you got that. I hope this is making sense to you guys. So 4 is remaining here. Let me use another marker. This is getting quiet. So what is remaining here is just 4. And then 4 raised to the power of 3 multiply 1 is going to give you 4 raised to the power of 3. We're going to expand it later. And then 0 multiply anything is going to give you 0. So what you have remaining here, for this part, we just have 4 raised to the power of 2x. That's what we have remaining here. Then minus, this 4 is multiplying everything now here. There's no more in denominator of 4 raised to the power of 2. So this 4 multiplied 3 will give us what? 12. Then open bracket, 4 raised to the power of x, which is what is remaining here. Hope it's making sense. And then minus 4 raised to the power of 3 multiplied to 1 will give us 4 raised to the power of 3. And if we expand that 4 raised to the power of 3, 4 times 4, 16. 16 times 4 is 64. Equals to 0. Why 0? Because 0 multiplied this 4 raised to the power of 3. Is still going to give you 0. That's what we have. And so, what do we do next? I'm also going to reverse engineer this. Look at what I'm going to do. I know that this 4 raised to the power of 2x can also be represented as 4 raised to the power of x 2. The bracket power law of indices. Where if you have something inside it, you have a base and a power inside, and then there is an outermost power. The outermost power and the innermost power will multiply themselves. And the reason why I'm doing this, so I'm going to replace this as 4 raised to the power of x, then square, then minus 12, 4 raised to the power of x, minus 64 equals to 0. And now that I've gotten the shape that I want, because you see that this 4 raised to the power of x is same thing as here, we can now represent this 4 raised to the power of x. We say let it become something. We say let 4 raised to the power of x become, let's say, p. So if 4 raised to the power of x becomes p, it's going to give that this becomes p squared. You see the reason why I had to reverse engineer it. Yes. So this becomes p squared minus 12. If he has been replaced with p, it's not going to be 12p. Because anyone you see p, we have replaced n of c 4 raised to the power of x to be what? Our p. Then minus 64 equals to 0. So we walked backward in order to arrive at this quadratic equation, which is our plan from the very onset. Now that we've gotten to this stage, I want to use quadratic formula and solve this real quick. And I'll just say using quadratic formula. I'll clean up here. But I'll not clean the original expression. I'll just clean up here to continue. Using quadratic equation, which is x is equals to minus b plus or minus square root of b squared minus 4ac over 2a. And using quadratic formula to solve this is already a quadratic equation. So our duty is to identify what is our a, b, and c. And we already said that previously that this is the framework of quadratic equation ax squared plus bx plus c equals to 0, where your a is the coefficient of the highest exponent. So here we just have p squared. I know there is no coefficient here, but there's an invisible coefficient here. What is the coefficient here? The coefficient here for this p squared is 1. So our a is equal to 1. Because it does not hurt. Come on, guys. It doesn't hurt. 1 is the coefficient here. Because if 1 multiply p squared, it's still going to give you p squared. So we've not really done anything wrong here. So a here is something as the coefficient of the highest order power of the exponent, just like we have here. This is the framework. So b here will now be the coefficient of what? This p here. And that is what? Not just 12, because sign comes before any given number or variable. So the coefficient of p here is what? Negative 12. So our b is negative 12. And then our c is what? Negative 64. We've gotten all that we need. So we'll just go ahead and what? Apply the quadratic formula. So it becomes that our x is now equals to, substituting the values of our a, b, c into this expression is going to be minus is already in the formula. So it's going to be minus, and our b is already minus 12. So it's something as, careful with the sign, please. Careful with the sign. Minus, open bracket, and have another word, minus 12. b is already negative 12. And the formula for quadratic formula also comes with what? Negative. So this becomes negative x equals to negative open bracket negative 12 for b, plus and minus square root of b again is going to now be minus 12 all squared, then minus 4 multiplied to a is 1, then multiply to c is negative 64. Let me write this out very well so that we'll have plenty space, so I don't go about missing one or two things. So x equals to minus open bracket minus 12 plus or minus square root of minus 12 all squared minus 4 open bracket 1 is the value of our a, and the c, which is here, is now going to be on negative 64 all over what? 2a is something as 2 times a, and our a is 1 here. So the next thing to do is just go ahead and simplify this. So can you do on how to get a number that has root 5 on compound interest? And can you rephrase? I don't seem to understand what you mean by that. But let's finish up with this, maybe in the next class, okay? Can you rephrase what you meant by that? Really appreciate it. Thank you for the comment. So this is what we have here. So we'll go on to simplify. Do the simplification. Start gradually. Don't rush it. Look at the minute things you can simplify and go on from there. So here having negative and negative. Negative multiplying negative is going to give you positive. So this is simple as saying just x equals to 12. Because now there's now a positive sign here. So simplify gradually. Then plus or minus square root of minus 12 squared is simple as saying minus 12 times minus 12. And minus will multiply first. Minus times minus is going to give us what? Positive. So the final answer here is going to be a positive value. And 12 times 12 will give us 144. Now this is where it gets tricky. This is where most people tend to miss it. Here you're having minus 4ac. This minus is for everything. This minus is multiplying everything here. So this is taken as minus multiply to 4, multiply to a is 1, then multiply to what? Negative what? 64. Now, minus will go and multiply this minus here, so that the end product of what we're going to get here is going to now be a positive value. Take note of that. And then this 4 will go and multiply what? 64. Let me multiply 64 times 4. 4 times 4 is 16. Carry 1. 4 times 6 is 24. 24 plus 1 is 25. So you have 256. So this is 144 plus 256. Then everything all over 2 times 1 is equal to what? 2. We are getting somewhere. So the next step now is to go ahead and add up these two together. In other words, I'm going to add it up here. 0, 0, 4. So we have 400. So I think it's looking like something we can actually do together. So let's go. So at this stage now, if you add this together, you know we're still simplifying. You add this together, you see that our x will now be equals to 12 plus and minus square root of 144 plus 256 is going to give us 400 divided by what? 2. We know what is the square root of 400 is equals to what? 20. Because 20 multiply itself is going to give you 400. So we replace everything here with 20 because the square root of 400 is 20. So x now is equal to 12 plus and minus 20 all over 2. And if you have that, if you have plus and minus in a given expression, it means like you have to evaluate for when it is plus and also when it is minus. So this implies that x is equals to 12 plus 20 all over what? 2. Or that x is equals to what? 12 minus 20 all over what? 2. So we have separated the plus and minus individually. So it's plus and then minus. So this is same thing as what? 12 plus 20 is going to give you 32 over 2. And that will give us 16. We're done with this. And then 12 minus 20 is going to give us minus 8 over 2. And that will give us what? Minus 4. So the value of our x is equal to what? Minus 4 or what? 16. But we can't really take that. Do we have to take that? We can't really do that because we can't really do that. Yes, we can't really do that. Because what we need to do, what we're looking for is p. And I forgot to mention, I use the x variable to solve because the general form of the quadratic equation. But what I was supposed to use was p. Because the quadratic equation we are considering is, let me remember, I think it was p squared minus 12p minus 64 is equal to 0. So in the real sense, what I actually find was p. So I'm so sorry for that. If there's a bit of confusion, please just leave it in the comment section. I'm going to clear you on that. I use the general form, this is the general expression for quadratic equation. But the variable that we chose to replace our 4 raised to the power of x is equals to what? P. Okay? So this is to say that whatever thing we solve for this given quadratic equation, it is the value of our P. So we are not done yet. What are we not going to do? Look at what we're going to do here. I'm going to clean here. I hope you guys are done with this so that we can now go back to where we switch 4 raised to the power of x to become P. So at this point, we're not going to say that, but our P is equals to 4 raised to the power of what? X. That's what our P is. And so, but we've got two values for what? For P. So it simply means that 4 raised to the power of x, replace it with P here, is equals to -4. Or that 4 raised to the power of x is equals to what? 16. This is what we're going to have. Yes. So if that is the case now, what are we going to do at this point? If 4 raised to the power of x is equals to 4 raised to the power of x is equals to -4, or that 4 raised to the power of x is equals to what? 16. We can go ahead and simplify this to become 4 raised to the power of x is equals to 4 squared, because 4 squared is equals to 16. So that at this point you have, since the bases are the same, the powers must be the same. That means our x must be equals to 2 for this side. But give me a moment. There's something I need to verify under this to be sure before we carry on. Okay. Now, this is what we have for x equals to what? 2. Now, if we come to this side, if we want to perform the same operation that we did here for this side, which is 4 raised to the power of x is equals to -4. Well, here we're having positive base of 4. Here we're having negative base of 4. You might expect us to do, this is simple as saying 4 raised to the power of x equals to -4 raised to the power of 1. But this and this, these two bases are not the same. Here you're simply having positive base of 4. Here having a negative base of 4. So at this point now, this does not apply. We're just going to leave it like this. It doesn't apply. So the exciting value that we've gotten for this stage is that our x is equals to what? Equals to 2. So this equals to 2 is going to be the one that will satisfy this expression. But to get this, we have to take another method, which is what? Taking the logarithm of both sides. And that is the next topic that we're going to get into. But the whole idea that I want you to get from what we've solved so far is how to use what? How to solve using factorization method and using quadratic formula to solve quadratic equation. And I hope you've gotten that. So at this stage now, this does not apply because 4 raised to the power of x is not equal to negative. Because it's negative here, we cannot go on. If it was positive, it would have just been, if this was positive 4, it would have just been easy, just become 4 raised to the power of 1, because anything that doesn't have a power originally has a power of 1, so that when I can now clear the base, and then equate the power so that x will now be equals 1. But we're having a negative. I hope you understand what this means. So it does not really apply here. So thank you. Okay, equation say calculate the annual rate of compound interest that will make 7,500 to grow to 126,400 at the end of 5 years. Please say if you can, having difficulties in how to find the numbers. Annie, I can't be able to do this now, so maybe I will send you a message later on. I don't know how you'll be able to communicate with me, so I will help you with this. But if you're on WhatsApp, you can send me a message on WhatsApp. 3, 4. Yes, you can actually send me a message on WhatsApp on this number with the question. Let me help you tidy that. I can't do that here in the live class. So thank you so much for joining. Now, in the next class, we're going to be entering the concept of logarithm. Logarithm. And that's actually something related to these indices. So the next class, we have actually done justice to indices up to a very high level. So if you've been following since we started this series last week, Monday, by now you should be solid on indices, and that's how I plan to continue. So I've already said it that I go live every Monday, Wednesday, and Friday. by 4 p.m. West African time. That's when I go live. So if you want to transition beyond knowledge to gain understanding, you saw how I was doing. I could have solved most of the question, but the whole idea is not to solve or to break it down in such a way that it's very, very easy to assimilate and for you to see what is going on in the background. And I usually pause at pivot moment to explain what is going on or what I'm about to do, what I'm about to explore. That is what I do here. And I just hope that you gain one or two from this particular section. Thank you so much for joining. So on Friday again, I'll be live by 4 p.m. I'll be looking at the concept of logarithm. Logarithm, where you have, if I have log a base b equals to x. Now, this x here, logarithm, just an introduction, is talking about how to get, the endpoint is getting the power that a particular base is raised to give a certain number. So you're given a large number and you're given a base. I have to find how many times you have to multiply the base to get that particular number, and that how many times now represent the power. So this given expression, this general form of logarithm, is something as saying that your a, this is pronounced as log a base b equals to x, where x is the power that the base has to be raised to give you this word, this value here. So it simply means that our a is equal to what? The base, which is b, raised to the power of x. Yes. So the value of what you have here is something as when you take the base of what you have here and raise it to the power of what you have on this right hand side. So that is basically it for today's class. I hope you learned one or two. Thank you so much for joining today's episode. If you want to reach out to me, also I'm on TikTok as, this is my TikTok username, at Uncle Sam 160. You can also reach out to me on TikTok. Then my Facebook, I'm also on Facebook as Uncle Sam online tutorial. This is for my Facebook and the Instagram. Okay, so you can always reach out to me and also follow to see more tutorial video. It's been an honor to spend this time with you, and I hope you gain one or two. Remember, we are transitioning beyond knowledge to gain understanding. But come on this journey with me, and I promise you, you'll never remain the same. We'll have it here. Transitioning beyond knowledge to gain understanding. Let's go! Vamos!